Hello everyone, this is Jyoti here from Real Education Center, and in this part of video we are going to discuss something more about triangle. So welcome to our series of triangle named Everything About Triangle. Let's begin. Look at this triangle. This is equilateral triangle. Now if I take this point, it is midpoint of this side. Alright? Now, if I want to take another midpoint or midpoint of this sides, let me draw this. Okay, so if I join them, this becomes my midpoint. Okay, so this point is midpoint of this side, this point is midpoint of this side, and this point is midpoint of this side. Now, what do we mean by midpoint? Let me show you. When I say midpoint, it means that point is dividing the line segment into exact two halves. Alright, so if I draw it something like this here, then this is also same. If I say these two are same, then see, these two are same. And if I say here this part, then this part is also same. Alright, so this is what midpoint is all about. Now, if I want to join this, let me draw it. See, if I take a line segment and from this vertex, if I join it here, okay, let me make it dark. Okay, so this is how we can join it. See, from this vertex, I join this midpoint. Similarly, from this vertex, I can join this midpoint. Alright? Similarly, if I join this vertex to this midpoint, see, if I join this, yes. Now, okay. Now you can see here that I have joined vertex to midpoint. Here also vertex to midpoint. And here also vertex to midpoint. So, all these line segments which are joining vertex and midpoint, these line segments are called median of a triangle. Right? So, these line segments are called median of a triangle. And this is what we are going to discuss about. See, what is median of a triangle? A line segment joining a vertex to the midpoint of an opposite side, and not only that, it is bisecting it. See, if we look at this figure itself, this is a line segment. It is joining a vertex, means this point. Let me take this. Vertex means this point to the midpoint. But midpoint of what? Midpoint of opposite side. See, this is opposite side. This side is opposite side of this vertex. Alright? And this line segment is bisecting this side. Means bisecting means making two equal halves. So, median is a line segment which is bisecting, which always bisect in fact the opposite side, right? Again, see, this is your vertex, and if you draw a line segment, okay, connecting to the midpoint of this side, then This is called median. So again, it's a line segment joining the vertex to the midpoint of opposite side. And because this is a midpoint, it is making two equal halves. All right. Okay. Similarly for this line segment also. Now we can see that a median connects a vertex of a triangle to the midpoint of the opposite side. So if you look at this from the viewpoint of this vertex, then you can say that from vertex to the opposite side. And if you look at this from the perspective of midpoint of this side, then you can say that from the midpoint to the vertex. In both the cases, there will be two equal halves. All right. So these line segments, which are called median, they always make two equal halves of opposite side. All these concepts are really very important because based on these concepts only, you will be solving the sums. All right. So remember this very well. Okay. All right. Now, see, if you look at this figure, then this is A, B, C, and AD becomes your median. See, in the triangle ABC, the line segment AD joining the midpoint of BC to its opposite vertex A is called median of a triangle. All right? So it's simple. If they already tell you that this is median, means you know that these are two equal parts. And if they tell you that these are equal parts, so again you can easily say that, okay, so then this is a median. So whatever the condition may be, in case this is given that this is median, then this should be known. And if this is given, then this should be known that this is median, right? Okay, so in triangle ABC, AD is joining the midpoint of BC to the opposite vertex, and so AD is called. See, this AD is called median of this whole triangle. Now, every triangle has exactly three medians, naturally, because there are three sides, right? And when there are three sides, the midpoint also three. Even the vertex three, right? Means there are three vertices. So naturally, every triangle has exactly three medians, one from each vertex, right? They all intersect each other at the triangle's centroid. Now, remember this. Let's go back to the figure. See, this point where all the medians are intersecting each other. See, let me draw it. So this point, just a minute. This point is your actually centroid. Okay, it's your centroid. This is called centroid. Okay, this centroid is really very important because if you cut a cardboard shape like this, and if you draw a centroid, and if you take a pencil or pen, and if you target this point of centroid, and if you try to rotate this triangle, the triangle will rotate very nicely. Why? Because all this, this is the center point. At center point, you can rotate the things very nicely, right? So it will not tilt in any direction. And that's why in geometry and in practical life also, this centroid is really very important. Okay, now, so they all intersect each other at the triangle's one point, and that point is called centroid. Now, there is one more result. Centroid always lie in the interior region of the triangle, right? Let's look at this. They are saying that centroid always lie in the interior region of the triangle. See, in case of this triangle, Here this is the centroid. Now, if I move this triangle, right? This is equilateral triangle. But if I change this triangle like this, see, now this is no longer equilateral triangle, okay? But still the centroid is in the interior region. If I make it 90 degree, means right angle triangle. See, even if I make it right angle triangle, the centroid is in the interior region. It's not only that, see, if I take it from this point of view, see, right? So from any point you take, okay, if you try to move this triangle in any point, but the result will be same. That is, the centroid will remain in the interior region of a triangle. So you keep it like this, or if you keep it like this, all right, or if you change it like this. In any which way, the centroid point is remaining same. That is, it will remain in the interior region of a triangle. So these are some very important features of centroid, or we can say point that is there because of the medians. All right. So what we have seen in this triangle, if you look at ABC, see this is triangle ABC, there are three medians, okay? One is AD, sorry, this is AD, BF and CE, okay? So they are intersecting at point O and this is your centroid. Now we will be discussing some more points but in our next video. Till then, goodbye.